All right, the last few lessons have talked about solving systems of equations. Well, this last lesson in the section 5.4, is on solving systems of inequalities. So here's our goals today. When you're done listening to this video or done in class, can you say this? I can solve a system of inequalities by graphing it, and I can determine whether a point is a solution to the system of inequalities. So before we start that, we have to review. I'm sure you've seen these symbols, but we have to review. So if you would get out a piece of paper and kind of write these down as we're talking, you can pause the video if you need to. But remember that one is less, one is greater. I don't know what you've chosen or how you remember things. I always remember that the sign points to the larger one, so I remember that these are greater than. I don't know if you learned anything about the alligator eats the bigger one, or the less than looks like an L, all those kinds of things. So these are greater, and this is less. This is less than, and this is greater than. Okay. And so what's the difference is with a less than and a greater than, when you graph it, you graph the less than or the greater thans. When you graph them, you have a dotted line. This is less than or equal to. So when you graph something that's less than or equal to, it includes the points on the line, so you need to make sure you have a solid line. And the same thing with this one. This is greater than or equal to. Would be a solid line when you graph them. Okay, and then if you're shading less than, we say that you shade below the line. Okay, you're going to shade below, and when it's greater than, you're going to shade above. And we're going to review, because you've done solving, you've graphed inequalities before. So that's why this should be a review. So I'm quickly reviewing the less than symbols, the greater than, which are solid, which are dotted, and if you shade above or below. So then I have a worksheet I want to look at. If you look at this warm up here, let's graph this. This is review. You've done it before. If you want to graph this inequality, you go to 5. You graph the boundary line first. The y-intercept is 5. The slope is -4. How do I know? Right there. So go down 4 over 1. The boundary line, because it's an or equal to, and I don't know if you can see that, but it's got a line underneath it. That's a solid line. And it says less than. So if I look at the y-axis, less than is down here. These numbers are less than. So here's how you graph y is less than or equal to -4x plus 5. And ideally, we should check a point over here. So over here is the point 0, 0. So let's see if it's true that makes that true. Is 0 less than or equal to -4 times 0 plus 5? So is 0 less than or equal to 5? Yeah. So that is the right side of the boundary line to change, to shade. So let's look at one more. We'll do number 2 together here, and then you can probably figure out when we're going to graph a system of inequalities, we're going to put 2 of them together. So let's look at this. The y-intercept is 3. The slope is down 1 over 4. It's a dotted line because it is not or equal to, and again, it's less than. So less than would be below. Okay, so the first thing before we can start talking about solving a system of inequalities is you need to know how to solve one inequality or graph it. And the idea is that all the points in the shaded area, there's an infinite number of solutions. All the points over here are solutions to the inequality. All right, so let's get talking to how to solve a system of inequalities then. All right, so to solve a system of inequalities graphically, graph each, and we're going to say boundary line, and see which points are in the overlap. So basically, you're just going to use the skills we just did and graph both of them at once. So here we know the y-intercept is 2, so we go to 2 on the y-axis. The slope is -1, right here. So down 1 over 1, down 1 over 1. It is a solid line because of the or equal to. And then it says less than, so less than is going to be below. So here would be less than. And if I want to graph the second one, -2 is the y-intercept, and -5 is the slope, so down 5 over 1. Solid line again. So it goes something like this. And this one says less than also. So less than would be everything over here. So where do they overlap? It may be hard to see, but if you look, where do the green and red lines cross? That's just red right here. That's just red. This is just green. So they overlap right here. I guess I'll make it blue. Okay, any point in that area is a solution to the system. So give at least one solution. At least one solution could be the point. Well, I guess I'm going to go with, to make sure, because it gets a little iffy there, but let's see, 1, 2, 3, 4. I'm going to go with -4, 0. And it says check. So if it's true, it makes both of these solutions true, both of these inequalities. So we have to check it in both. Is 0 less than or equal to -1 times -4 plus 2? So is 0 less than or equal to 4 plus 2? Well, that's true. Okay, so then let's check the other one. Is 0 less than or equal to 5 times -4 minus 2? So is 0 less than or equal to 20 minus 2? Yep. So all of the points in the blue is a solution to the system of inequalities. So basically, to solve a system of inequalities, you need to graph each one and find where they overlap. Make it solid or dotted based on what you see here. And you should be good. What I want to talk about is sometimes, though, we can have, let's look at this one. Sometimes there can be no solution to a system if you graph them and they don't overlap, and that's only going to happen if the lines are parallel. I believe this is an example. So let's do this one and we'll see. So let's graph the boundary lines. The y-intercept is 3. The slope is 3, so I'm going to go up 3 over 1. And it's a dotted line this time. And this first one says greater than. So that's over here. You can see this one, the y-intercept is -2. It's the same slope, so we know, we've learned before that it's parallel. They're going to be parallel. And this one says less than. So less than's down here. So it turns out this system of inequalities, they don't ever overlap. There's no solution. So it can happen that there's no solution to the system. Okay. All right, we talked about determining whether a point is a solution to the system. You can do one of two things. You could graph it and then check if that's in the shaded area. Or if you don't want to graph it, you could just put it in. Put this in for x and put this in for y and see if they're true. So let's put 4 in for y. Is -4, is that less than 1 minus 1? So is -4 less than 0? Yeah, -4 is less than 0. Let's try it in this one. Is -4 less than 2 times 1 minus 2? So is -4 less than 0 again? Yeah. -4 is less than 0. So this is a solution to the system. All right. I would like you to consider this website, desmos.com. You can go to your computer and punch that in, um, and go to that website and launch the calculator. And it's a really neat website that lets you punch in the inequalities and graph them right there. All right, and you can talk to me in class about it, but I would look at that website and use that as kind of an interactive tool and kind of a graphing calculator to graph these inequalities. It'll graph them right there for you. All right, so after this lesson, you should be able to solve a system of inequalities. We talked about how to solve a system of inequalities by graphing, and we talked to you about how you can determine whether a point is a solution. You can either check to see if it's in the shaded area, or you can put it back in and see if it makes both of them true. All right, so go ahead and take quiz 5.4.3 when you're ready.